Hi, welcome to the flipped instructional session for Math 08B on Unit 308, Volumes of Composite Figures. Today, our objective will be to determine the volume of a composite figure involving cylinders, cones, and spheres. So as a reminder, volume of a cylinder is pi r squared h. The volume of a cone is 1/3 pi r squared h. And finally, the volume of a sphere is 4/3 pi r cubed. And remember, all of these have cubic units as the measurement. So we are just talking about a volume of a cone, a cylinder, and a sphere, which we just went over. Cubic units. And the volume is the number of cubic units that fill up this shape. So a cone a cylinder, and then finally a sphere. So the amount that takes to fill these shapes. Let's take a look. Stephanie built a box to hold sports equipment. The box is in a shape of a rectangular prism. So we're talking about a box here. The volume is 20 1/4 feet cubed. And again, we can see this cubic units here, so we know that's a volume. The area of the base is at 6 3/4 feet squared. So the base, they already gave us the area. So the length times width, they already gave us, so we don't have those individual measurements, but we have the area, which is length times width. They want to know the height. So just like in all of our other shapes, the volume, we have the area of the base times the height. So 20 1/4 feet cubed. So 1/4, you could put 1/4 in your calculator to get that decimal, but 1/4 is 0.25. So 20.25 is equal to the area of the base, 6 3/4. Again, you could put 3/4 in your calculator to get that decimal. That's 6.75. What is the height? So to get height by itself, we divide both sides. So the height is equal to 20.25 divided by 6.75. I'm rechecking mine here because I think I must have hit something wrong on my calculator when I did it. It didn't make sense. 20.25 divided by 6.75 is 3. And we're talking about height, so that's a one-dimensional measurement, so that's feet. Two-dimensional was the area, right? 2 dimensions. Length times width, that's 2 dimensions, so that's why we have feet squared. 3 dimensions is the volume, which is why we have feet cubed. So that is extremely important. All right, so which figures make up the composite figure? So a composite figure is just a figure made out of more than one shape. And so let's take a look. If we look at this shape, we see there's this triangle up here, but it's going to have a circular base to match this circular base. So right here, I see a cylinder, and up here, I see a cone. So we have a cylinder and a cone, and so what we're going to find is that we can find the volume of a composite figure by finding the volume of each individual part. So that's what we're going to do. We're going to find the exact volume. And remember, when we talk about exact, we leave everything in terms of pi. We don't put in 3.14 for pi. We keep pi in our answer. So we have the volume of the cylinder plus the volume of the cone is going to be the volume of the figure. So volume of a cylinder, pi r squared h. Volume of a cone, 1/3 pi r squared h. So volume of the cylinder, which is this part down here. Let's highlight that a little bit. So here is a cylinder. Pi r squared. So right here, 8 is the diameter. The radius is half of that. So 8 divided by 2 is 4. So pi r squared. The height of the cylinder is 18. So that's the cylinder. The cone, 1/3 pi. Radius is still 4 because this didn't change. Now the height of this one, let me highlight this. We see it's just this part. That's the height. So this part, how do we find that? Well, if this total is 24 and this part is 18, we can say, okay, this part right here must be 24 minus 18. So 24 minus 18 is 6. So this height is 6. So let's multiply this out. So I'm going to leave the pi, r squared h. So 4 squared is 4 times 4 times h. So this is 288. So really the better way to write this, is 288 pi. Remember, we're doing exact volume, so we keep the pi plus, now I can do 1/3 times 4 squared times 6. So one way to do that is 4 times 4 for 4 squared times 6 divided by 3, because that's 1/3. So 96 divided by 3 is 32. So 32 pi. Now we add this together. 288 plus 32 is 320 pi. And our units, we see your feet, so feet cubed. That's how we find the exact volume. And we treat this pi just like it's a variable, like if this was an x. 288x plus 32x would be 320x. So we're treating this pi just like a variable. And that's how we find exact as opposed to a decimal form. Let's try another one. So now we see we have, this is a half sphere down at the bottom. So I see and then we have a cone on top. So let's do the half of the sphere first. And again, it's asking for exact, so we're going to leave it in terms of pi. So volume of, it's really a hemisphere. I'm just going to call it a semicircle. Semisphere. That sounds weird to me. Volume of hemisphere plus the volume of the cone. So a whole sphere would be 4/3. Half of 4/3 is 2/3. So 2/3 pi r cubed plus 1/3 pi r squared h. So 2/3 pi r, half of the diameter, so 9 cubed. Equals, not equals, plus, sorry, plus 1/3 pi r, again, is 9. So 9 squared h. What is the height? So keep in mind, from here to here, because it's a sphere, is the radius. So this right here is 9. This total was 21. So this part right here is 21 minus 9. So 21 minus 9 is 12. So this height is 12. So 9 cubed means 9 times 9 times 9 times 2/3 is 486. So 486 pi. Don't forget the pi. We're treating that like a variable. Plus 9 squared, or 9 times 9, times 12 times 1/3 is 324 pi. Don't forget the pi. Then we can add these together. 486 plus 324 is 810 pi. Again, remember, we're treating it like an x. Centimeters cubed. There's one additional problem that we'll go through in the flipped follow-up session that is actually where we subtract, or we take out a shape within a shape. So look for that on your Class Connect. For the flipped follow-up, you can also attend the Help Lab for more help on these problems. And a live session is a great place to come and ask questions and work problems. Thanks so much.